In the previous video, we talked about how we could use formation reactions in order to calculate the standard enthalpy of reaction. Let's now talk about how we could use combustion reactions to do the same thing. And so right now we're going to talk about the enthalpy of combustion method for calculating delta HR. Alright? Now you've seen combustion reactions before in chapter 4, but just to redefine them, a combustion reaction is when you have some sort of molecular species and that molecular species is oxidized with O2 gas to form some specified product. For example, if we have propane gas, 1 mole of it, we could react it with 5 moles of oxygen gas, or in other words, we could combust it with 5 moles of oxygen gas to form 3 moles of gaseous carbon dioxide and 4 moles of H2O liquid. And for this reaction, the standard enthalpy of reaction is negative 2,220 kilojoules. Okay? And so this is a combustion reaction. One thing I want to point out is that combustion reactions not only happen with organic molecules, but they could also happen with other species as well. So things containing sulfur or nitrogen atoms can also combust. Okay? And so this is what a combustion reaction is. And so the standard enthalpy of combustion of a species, so let's say that same propane, and I'm going to abbreviate the standard enthalpy of combustion as delta HC with a degree symbol. That's just going to be equal to the standard enthalpy of reaction of a species when it's combusted. And so in other words, if we go back to propane, it's delta HC is going to be equal to negative 2,220 kilojoules. Alright? And so that's what the enthalpy of combustion is. Now, similar to what we saw with the enthalpy of formation, when we're dealing with enthalpies of combustions, by definition, what we're going to say is that the enthalpy of combustion for any species that's a combustion product we're going to say its enthalpy of combustion is equal to 0. Alright? So for example, the products include the carbon dioxide on the right hand side, the H2O on the right hand side, or if we're dealing with sulfur, SO2, or nitrogen, NO2, things like that, etc. And enthalpy of combustions are typically defined for reference temperatures of 25 degrees C and P is equal to 1 atmosphere. Enthalpy of combustions, just like the enthalpies of formation, those are typically values that are tabulated, and you can look them up in different tables. And in our case, these enthalpies of combustions for many species are listed in our textbook, also in Table B1. So if I go back to the electronic version of the textbook, and I look at Table B1 again, if I look at the last column there on the right, that's what that column lists the enthalpy of combustion values, the delta HCs, for various species. And once again, for some species like acetic acid, you could see that the enthalpy of combustion is listed for different phases. So for liquid acetic acid, the enthalpy of combustion is negative 871.69, while for the gas, it's negative 919.73. Okay? And so we could look up the enthalpy of combustion values for various species. And with that information, what we could do is that we could once again use Hess's law to calculate the standard enthalpy of reaction for some reaction. And so for any arbitrary reaction, so for a reaction, we could calculate its standard enthalpy of reaction using this formula. Calculated via, so what we have is our standard enthalpy of reaction, delta HR, degree, and that's going to be equal to the sum of the reactants, and so we're taking the stoichiometric coefficient in some reaction times its enthalpy of combustion. And what we're subtracting off is the products. We're once again taking the stoichiometric coefficient and multiplying it by the enthalpy of combustion. Now the big thing that you'll notice is the order we have here is the opposite of what we had for the enthalpy of formation. So in the enthalpy of formation, we were taking the sums of the products and subtracting off the sums of the reactants. But here we have the reverse. We're taking the reactants and subtracting off the products. Now I want you to think about why the order is like this. So we now defined an equation that allows us to calculate the standard enthalpy of reaction for any reaction by using the enthalpy of combustion values for the reactants and the products. Let's now practice using this equation by working through example 9.4-1 in the book. So we'll work through this example. And so what this example is asking us to do is it's asking us to calculate our standard enthalpy of reaction for this reaction. So C2H6, so ethane, yields ethylene, C2H4, and hydrogen gas. Okay? So, in order to calculate this delta HR, what we need to do is go to table 1 and find the enthalpy of combustion values for each of the different species. Table B1. Okay? And so at this point, I want you to pause the video and I want you to look up the enthalpy of combustion values for each of the different species in this reaction. Let's now continue. From table B1, we could find that the enthalpy of combustion for ethane gas is equal to negative 1559.9 kilojoules. For the ethylene gas, the enthalpy of combustion is negative 1411 kilojoules. And then for H2 gas, the enthalpy of combustion is negative 285.84 kilojoules. And so to calculate the standard enthalpy of reaction, we're going to use the formula we defined on the previous page, where we have the reactants, the magnitude of their stoichiometric coefficients, and we're subtracting this product from this product, the products. And so let's plug in the values that we found from table B1. Okay, and so let's start with the reactants. What we have is 1 mole for the ethylene gas, or ethane gas. And so we're going to multiply this 1 by the enthalpy of combustion. Alright, and from that we're going to subtract off the sum of the products. So on the product side we form 1 mole of the ethylene, and so we're going to multiply its enthalpy of combustion, and we add on 1 mole of the H2 gas's enthalpy of combustion. And if we sum everything up, we get a value of 136.9 kilojoules. And so by using these enthalpy of combustion values, we could also get the standard enthalpy of reaction.